$100 versus $12,000. $100, that is what a trombe wall costs in basic materials: concrete, black paint, a sheet of glass. $12,000, that is what a new central HVAC system costs installed in the average American home. The $100 wall reduces heating bills by up to 84%. It has zero moving parts. It requires zero fuel, zero electricity, zero maintenance, and it lasts the lifetime of the building. The $12,000 system lasts 15 years, needs annual servicing, burns gas or electricity every single day, and the manufacturer hopes it breaks just after the warranty expires. A study in Iraq built an entire functional trombe wall for $101.40. Total, why is this not on every south-facing wall in America? That is the question this video answers, and the answer is not complicated. It is just ugly. Let me explain exactly what a trombe wall is, because once you understand the physics, you will never look at your south-facing wall the same way again. A trombe wall is a passive solar heating system. Passive means no machinery, no compressor, no blower motor, no circuit board, no thermostat, nothing that plugs in, switches on, or breaks down. It is a wall that heats your home, using nothing but sunlight and the laws of thermodynamics. Here is how it works. You take a south-facing wall, the wall that gets the most direct sunlight in the northern hemisphere. You build it out of a dense thermal mass material, concrete, brick, stone, or adobe, 8 to 16 inches thick. You paint the exterior surface black or a very dark color. Then you mount a sheet of glass, single or double glazed, about 4 inches in front of that dark surface, creating a sealed air gap. Now, when sunlight strikes that wall, 3 things happen. First, the shortwave solar radiation passes through the glass and hits the dark surface. Second, the dark surface absorbs that radiation and converts it into heat. The surface temperature can reach 150 degrees Fahrenheit. Third, that heat tries to radiate back out, but now it is in the form of long-wave infrared radiation, and glass does not let long-wave radiation pass through easily, so the heat gets trapped between the glass and the wall. This is the same greenhouse effect that warms the inside of a parked car in summer. But instead of heating air that escapes when you open the door, this heat is being driven into a massive wall of concrete or stone. Now here is where physics does the rest. Heat moves through concrete at roughly 1 inch per hour. So if your wall is 8 inches thick, it takes approximately 8 to 10 hours for the heat that entered the outer surface at 10 in the morning to reach the inner surface. By the time that happens, it is evening, the exact hours when you need heat the most. This delay is called thermal time lag. The wall absorbs solar energy all day long, stores it inside its mass, and then releases it as gentle, radiant heat into your living room all evening and all night. By dawn, the cycle is complete. The sun comes up, and the wall begins recharging. No battery, no fuel, no timer. The wall itself is the battery. According to Wikipedia's compilation of published studies, the original trombe house at Odilo, France, built in 1967, received 70% of its yearly heating from this single wall. 70% from concrete, paint, and glass. And the trombe wall converts 70 to 80% of the sun's radiation into usable heat. Compare that to photovoltaic solar panels, which convert only 15 to 20% of radiation into electricity. On pure thermal efficiency, a trombe wall outperforms a solar panel 4 to 1. This is not new technology. It is not experimental. It is not theoretical. It has 145 years of documented history. In 1881, a man named Edward S. Morse of Salem, Massachusetts, filed a patent with the United States Patent Office. Patent number 246,626. Title: Warming and Ventilating Apartments by the Sun's Rays. The filing describes a south-facing, glazed box with a dark absorber surface and vents at the top and bottom to circulate heated air into a room. That was 1881. Before most American homes had electricity, for decades, the concept sat dormant. Then, in the 1940s, a French engineer named Félix Trombe, a man who would later build the world's largest solar furnace in the Pyrenees Mountains, capable of generating temperatures above 5,000 degrees Fahrenheit, began researching passive solar systems. In 1967, Trombe and architect Jacques Michel built a house in Odilo in the south of France. The south-facing wall was 2 feet of solid concrete, painted black with double glazing on the exterior. No vents, no fans, pure thermal mass and radiation. The results were extraordinary. 70% of all heating came from that wall, published in multiple academic papers, verified. 3 years later, a second trombe house was built in Montmoody, France, a living space of 280 cubic meters. It needed 7,000 kilowatts of heating annually. The trombe wall supplied 5,400 of those kilowatt hours. The remaining electricity cost the homeowner approximately $225 per year, compared to an estimated $750 for a conventionally heated home in the same region. That is a 77% reduction in heating load and a 70% reduction in heating cost. Then it crossed the Atlantic. In 1974, architect Douglas Kelbaugh built a house in Princeton, New Jersey, the first well-documented trombe wall home in America, a 2-story structure with 600 square feet of thermal storage wall made of concrete and painted with selective black paint. Over the winters of 1975 to 1977, Kelbaugh collected detailed performance data. The results? Heating cost reductions of 76% in the first winter and 84% in the second. Published, peer-reviewed, reproduced. So by the late 1970s, you had verified trombe wall performance across 2 continents, multiple climates, and more than a decade of data. The United States Department of Energy published guides. The National Renewable Energy Laboratory produced detailed reports. Architects from New Jersey to Utah were building these walls into real structures. Then oil got cheap again. In 1986, Ronald Reagan ordered the solar thermal panels removed from the White House roof. Federal funding for passive solar research was slashed, and the HVAC industry, which had been growing steadily since Willis Carrier invented mechanical air conditioning in 1902, resumed its trajectory toward becoming the $500 billion global machine it is today. Let me lay out the economics, because this is where the story becomes personal. According to the Energy Information Administration, more than half of all energy used in American homes goes to heating and air conditioning. Space heating alone accounts for 42%. The average American household will spend between $976 and $995 just on heating this winter. According to the National Energy Assistance Directors Association, that is up nearly 8% from last year. And these costs have been climbing steadily for decades. Over a 15-year HVAC lifespan, the average homeowner pays roughly $7,500 in installation, $3,750 to $7,500 in annual energy costs for heating alone, and between $2,250 and $4,500 in maintenance and repairs. That is a total cost of ownership between $13,500 and $19,500. For one system that will need full replacement in 15 to 20 years, and then you start the cycle again. A trombe wall costs between $100 and $500 in materials for a do-it-yourself installation. A professionally installed trombe wall retrofit might run $1,000 to $3,000, depending on size and glazing quality. It has no moving parts to maintain, no filters to change, no refrigerant to top up, no annual service contracts. Concrete does not expire, glass does not wear out. Black paint can be reapplied for a few dollars every 10 to 15 years. The wall lasts as long as the building exists. A 2022 study published in the Journal of Renewable and Sustainable Energy reviewed trombe wall retrofits and found a 72% reduction in total annual energy consumption compared to existing homes. Another study found that integrating phase change materials into a trombe wall can push winter energy savings up to 55%. Even the most conservative, peer-reviewed estimates consistently report a baseline savings of 20 to 30%. Now apply that to the national scale. There are approximately 140 million homes in America. The average household spends about $1,346 per year on heating and cooling combined. If trombe walls reduced heating costs by even a conservative 50% in just 10% of those homes, 14 million homes, that represents over $9 billion in annual savings removed from the energy industry's revenue stream. Every year, forever. No recurring costs. The global HVAC market is worth $564.8 billion in 2026 and is projected to reach $1.2 trillion by 2035. Lennox International alone operates on a 21.3% operating margin and a 15.7% profit margin. Carrier Global pulls in over $20 billion in annual revenue. These companies sell machines that break, need replacement, and consume fuel every day of their operating life. A wall that costs $100 and works forever is not innovation to them. It is a threat. If the HVAC industry buried this technology, there must be no modern examples. Right? Wrong. The Zion National Park Visitor Center in Utah is one of the most studied low-energy buildings in the United States. Designed in collaboration with the National Renewable Energy Laboratory, the building uses a trombe wall as a core part of its heating strategy. The south-facing masonry wall absorbs solar energy during the day and radiates warmth into the building at night, with the inner wall surface reaching approximately 100 degrees Fahrenheit. The result, published by NREL and the Department of Energy, the Zion Visitor Center, uses 67 to 70% less energy than a comparable building that meets standard federal energy codes. 67 to 70% less. And the construction costs were comparable to a standard building. It is not experimental. It is open to the public. You can walk through it today. Arch Daily documented for modern projects featuring trombe walls across different climates. MDPI published a comprehensive 2023 feasibility review confirming the technology works in mild and cold regions. The Virginia Administrative Code, Title 13, Section 5200-130, specifically includes provisions for trombe walls. The technology is legal, it is proven, it is documented. It is just not profitable for the industry that controls your heating bill. I am going to be honest about limitations because a useful video respects your intelligence. A trombe wall works best on south-facing walls in climates with clear winter sunshine. If your home faces north, or if you live in a region with heavily overcast winters, the system's efficiency drops. It is climate-dependent. Summer overheating is a real concern. Without a shading strategy, a trombe wall will continue absorbing heat when you do not want it. The solution is a roof overhang, exterior shutter, or seasonal shade device. A study from Solar Energy Journal found that shading and ventilation reduce unwanted cooling loads by up to 72.9%. A full-height trombe wall blocks daylight on that wall. You lose the window. The architectural solution, widely used since the 1980s, is a half-height trombe wall combined with windows above it for light and views. Building codes in some jurisdictions limit the amount of south-facing glass or impose thermal performance requirements that inadvertently discourage passive systems. These are not technical failures, they are regulatory ones. The National League of Cities published a 2026 report identifying zoning barriers to solar design, including height restrictions and glazing area limits. None of these limitations are fatal. They are design parameters. Every heating system has constraints. The difference is that a furnace's constraints cost you $1,000 every winter. A trombe wall's constraints are solved with a roof overhang and a tape measure. Here is what you can build. If you have a south-facing wall that receives direct sunlight for at least 4 to 6 hours during winter days, you have everything you need. For an 8-inch concrete wall, the thermal time lag is 8 to 10 hours. Build it, and the heat from a sunny 10 a.m. reaches your interior by 8 to 10 p.m. For a 12-inch wall, the lag stretches to about 12 hours. For a 16-inch wall, you get the longest storage and the most even heat distribution. You need concrete blocks or poured concrete for the thermal mass, a selective dark paint or coating on the exterior face, tempered glass, single or double glazed, mounted on a frame 4 inches from the wall face. And that is the entire system. The National Renewable Energy Laboratory published a full technical report, document number NRELCP 550-36277, titled Trombe Walls in Low Energy Buildings. Practical experiences. It is freely available online. It includes design guidelines, performance data, and lessons learned from real buildings across the United States. The Department of Energy's Passive Solar Homes page provides additional guidance. Both are taxpayer-funded public resources that cost you nothing to access. In 1881, Edward Morse patented a wall that heats a room using sunlight. In Ijoloti, Felix Trombe proved it could supply 70% of a home's heat. In 1974, Douglas Kelbaugh proved it cut heating bills by 84%. In 2000, the National Park Service built one in Zion that saves 70% of energy. And in 2026, the average American homeowner is still paying $1,000 a winter to run a machine that will break in 15 years. $100 versus $12,000. The question is not whether this wall works. That was answered 50 years ago. The question is, why nobody told you? If this video reached you, the answer just changed. Share it. Build it.